So you were saying about the standard deviation, and you're just saying about the last class. So in the last class, we have discussed about the central tendency of the data basically. So we can say we can define as the mean, median, mode. These are the central tendency. And then we have done the dispersion of the data. So in that one, we have done the standard deviation, mean deviation, and variance. After that, we have done the percentile and quartile. These formulas we have done in the last class, all are the formula based things that we have used the formula and we can calculate the required things just to find out the information or analyze the data and how we represent the data basically. So that's we are doing we have done in the last class. So if you want to mention here the formula for the standard deviation, so I will show you. I think in the last class, yes. This is the formula for the standard deviation. So this is the formula, that is xi minus x bar whole square divided by n minus 1. So it is basically, we are just taking here as we can say here that we are doing here the variance. Variance is what? Xi minus x bar whole square divided by n minus 1. Okay. Notes, actually they are not proper notes. That's why I'm not uploading it. We are just writing in the form, in a very rough form, and just to explain the things. That's why I'm not uploading it. But on the time of a recording, when you see the recording, you can find out these notes also. Okay. Now we can say xi minus x bar whole square upon n minus 1, and we are taking the square root of it. So that will give you the standard deviation. Okay, you just try your own and then you just let me know what the problem you had to calculate the standard deviation. Okay, so after defining these chapter, we have started the chapter as a probability. So now we are just using the probability concept. So in that one, we have done the sample space, events we have defined, and then we have defined the mutually exclusive events. Okay, and then we can just use it other terms also. So the probability which we are trying to calculate, it is based on the number of favorable cases divided by the number of total time of things. So before it, that we can find out the possibilities. Actually, in the section 3.2, we are just doing the counting, and that counting is just to find out the probability. Okay, firstly we just do the counting, and then based on this counting value, we can use the probability. Okay, so the formula probability that we will discuss later, but firstly we will just do the counting. And this type of these 3.2 and 3.3, it's already uploaded in the slides, but it was not covered in the last class. That's why I'm again taking it. Okay, so counting is sometimes it is very difficult to determine the number of elements in the sample space by direct enumeration. So we have done in the last class, if you remember, we have done in the last class that we are finding the sample space S by using the some experiment. Okay, so we are finding how many elements in that one and what are the elements. So in the last class, we have done the tree diagram to find out the elements. For example, we have done this, just a second, this one, this example we have done. Okay, so in that one, in this one, we are just finding the sample space here by using this tree diagram. Okay, so there are several ways to define the tree diagram, and we just to define the sample space. Now sometimes it's very difficult to determine the elements. uh, I will explain it, but in the last class also I just explained 2 times, and you just go through the slides and just ask the pinpoint doubt actually. Okay, so this example we have done to calculate the sample space. So now we are just saying it's very difficult. Yes, you were attending the last class, but just go through the recording. You will get, definitely you will get. Okay, so just wait. Firstly, I will cover up the elements, then we will just go for that. Okay, fine. Just wait. Firstly, we will just do this counting part, and then we will do it. Okay. So, by direct enumeration, it's very difficult to find out the elements, number of elements in the sample space. So, what we will do, just for example, it is given old cars in a city can be classified as low, medium, or high current mileage, moderate or high speed, inexpensive, average, or expensive. So, total there will be 18 possibilities. Can you define it as? So, firstly, they classified as a mileage based, moderate or inexpensive and expensive ways. Okay, so so many ways that we are finding. Okay, a car having the low mileage, high speed, average expensive, and so on. So it's very difficult to make a sample space. So what we will do, we are not finding the elements, all elements. We are finding how many elements are possible. Okay, number of elements. So that's we will do by using the counting process actually. Okay, so here we are saying this is 18 possibilities how we can do it. If you're just seeing this case, so you can see here there are three ways for the mileage. Okay, and two for speed. There are two options for the speed and two options three options for the price. That is inexpensive, average, or expensive. Okay. So now, how many ways we can make the possible combination for expensive? We can say the first mileage, then speed, then price, and three elements we are making here, and we are just saying how many possible combinations. So it's very difficult actually. Just we have to make all possible combinations. So what we will do? How many elements we can find out? So what we will do? We are just multiplying to each other. So that is the counting. So 3 multiplied by 2 multiplied by 3. So there are 18 possible ways to make a total outcomes of the experiment. Okay. So that is the purpose of the calculating the counting actually. So the previous example. Okay. And this is the N1 ways. Not audible. Slides are visible. Okay, fine. Visible. Now good. Now audible. Okay. Maybe some problem at that time. Now it's visible and slides are visible and I'm audible. Okay, fine. Thank you. So you can see here there are three contains that sets A1, A2, A3, and there is a N1, N2, Nk ways. So we can say the N1 multiplied by N2 multiplied by Nk ways of choosing first an element of A1, then an element of A2, then finally an element of AK. So this is known as the multiplication method or multiplication formula to calculate the number of ways, number of possible ways to calculate the number of elements in the particular sample space, basically. Okay, that how much possible ways to that experiment can run and give the output. Okay, so this is known as a multiplication rule actually. Second is coming as a permutation and combination. You have done, I believe, that there are two are things which we can calculate counting. So in this one, a permutation is an arrangement of objects in a definite order. Okay, we have to mention the order also. But if it is order is not required, only we are arranging or we are selecting the objects without regard to order, so that we are using the combination. So there are two things we are doing here, permutation and the combination. Just a minute. Okay, so this is the two permutation and combination. So when we are just arranging the objects in a definite order, so at a time we have to use the permutation. But if we are just selecting the objects without taking the order, okay, for example, randomly I am picking the 5 students to discuss something about the doubt. Okay, so for example, right now also you can see, just I am asking, okay, slides are visible or not. So 5, 6 students are giving me the reply that they are visible. Okay, so I am selecting these results actually. So that is the without order, that who is giving the first answer. So that is the combination we have to take. But if we are just giving in the finite order, for example, ID wise, if we are doing it, so that is we have to use permutation. That first ID, 5 IDs I am just selecting, and we are discussing something about the visibility of the slides. Okay, so that is we are using how we can make a permutation, that out of 62 students, because right now there are 62 students are attending the class, and I just arrange them ID wise, and I just say that we are picking 5 students out of 62 students. So by ID wise, we are Again, there was a problem. Yes. It means I'm now okay. I think there is some problem in the last 5 minutes. No audio. Okay. I don't know. Okay, fine. Now it's okay, na? Actually, 1 minute, for 1 minute, I just took the break because I have to drink the water. Okay, fine. But after that, there was I think there's some problem with the network issue. Okay, now come to the permutation combination. After that, I already told you the multiplication principle. So let us consider an experiment in k stages. Let ni denotes the number of ways in which I can occur for I is equal to 1, 2, 3, 4, 5 up to k times. So totally the experiment can occur in the n1 multiplied by n2 multiplied by n3 up to nk ways. Okay, this is the same thing as I have done a3 multiplied by 2 multiplied by 3 ways. Okay, so there are 3 ways for the calculating mileage. There are 2 ways to calculate the speed. There are 3 ways to calculate the price. So at a time we are finding the n1 multiplied by n2 multiplied by n3 ways. So that is the multiplication rule. So these are the basically we are doing here the counting process. Okay, one student are showing the hand. Okay. Okay, so in this one we have done the 3 parts basically. One is you can say the permutation. Second is we are doing permutation. And second is we are doing combination. Third, we are doing multiplication. Okay. So these are the 3 important ways to for the counting. Okay. And why we are doing the counting? Because we are not able to identify or write the all elements of the sample space by using the tree diagram. So what we will do by the counting process, by multiplication, by permutation, by combination, it depends upon the what type of question we are having. So based on that, we are calculating the number of elements in the sample space basically, and similarly number of elements in that particular event. Okay, so that is the concept which we are using here. So now the permutation and combination, when we are saying the permutation, so it is denoted by the permutation is denoted by NPR. And here this is equal to NPR. It is equal to the n factorial upon n minus r factorial. Okay, I believe that you have. I will give you. Don't worry. Okay, I believe that everyone knows about the factorial. I believe that you know about the factorial concept. So what is the meaning of factorial? And factorial is means what? 1 multiplied by 2 multiplied by 3 multiplied by 4 up to the n. Means what? 5 factorial if we are talking about. So it is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. That is our factorial. So if we are just talking about here 6p4, so it means what? 6 factorial upon 6 minus 4 factorial. That is equal to the 6 factorial upon 2 factorial. So if we just calculate it, so what is this? 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 2 multiplied by 1. So 2 1 multiplied by this, and we are having this value actually. Okay, so this is the permutation. Got it? The second is the combination. Combination is denoted by NCR, and somewhere it is denoted by the bracket and NR. Okay, that is also be a symbol for the combination. And combination means what? We are selecting the object without order. Okay, randomly we are picking some objects here. Okay, for example, there are 66 students are attending the class, and I want some feedback from your side. And I am just saying, okay, on my screen, there are 4 students. Their name of the 4 students are flashing here. So I just say, okay, is the slides visible? For these 4 students, I am just asking to these 4 students only. For example, if I am just opening and I will allow them to say something. Okay, so I am picking the one example we can take like this one, that 5 students are raising their hands. Okay, and I am just trying to allow to speak. So randomly I am picking one student and unmute them. Got it? Okay, so at the time randomly I am picking it. Yes, selecting the pupil. That is the combination here. Okay, but if we are arranging the objects, okay, pupil means we are talking about the yes, who is responding. So in this one, what we are talking about, that we are just taking the ID wise only, that first person, this one is responding, this one is, we are making them in arrange, we are making in order. So that is, we are using the permutation basically. Okay. So that is, we are using NCR and SCR, and the formula is what? N factorial upon R factorial into N minus R factorial. Okay. So this term is extra in the denominator. R factorial term is the extra term, which is we can consider with the combination in that one. Now we can say, for example, 6C4 is what? 6 factorial R factorial into 6 minus 4 factorial. So now it will become 6 factorial upon 4 factorial multiplied by 2 factorial. Okay. So this will change the value. So now you can say here 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 4 factorial. So it is this, and multiplied by 2 factorial, 2 factorial by 1. Okay. So we can just cancel out this part, and 2 is cancel out 3. So that will become here 15. Got it? So this is the combination we are taking. Okay. Next thing is what? That permutation of indistinguishable objects, that we are arranging the items in items, but they are indistinguishable. Means what? If we are just taking the one example, that a bag having the six means they a bag having the 10 balls. 1 minute. 10 balls. But in this one, we are taking there are 3 color ball. Okay, means blue, green, and red. Okay, so there are 3 balls of blue, 2 green, and 5 red balls. Okay, so they are different also, as well as they are same also, because 3 balls are blue, 2 balls are green, and 5 balls are red here. Okay, so that is the concept when we are using, this is the indistinguishable, because 10 balls we are considering. So here 3 balls are blue, 2 balls are green, and 5 balls are red. So in this case, we are talking about the indistinguishable objects, because if we're talking about the red balls, so there are 5 different balls, no? So we can't distinguish them. Okay, so at the time we are just taking the permutation of indistinguishable objects, and that formula is what? N factorial upon N1 factorial multiplied by N2 factorial multiplied by, say, Nk factorial. And we know that N1 plus N2 plus up to Nk, it should be N, total number of elements actually. Okay, in this example, what we are saying here, N is equal to 10. N1 is what? 3. N2 is what? 2. And N3 is what? 5. So if we are taking the permutation, example means what? A bag having the 10 balls. Okay. But they are not having the numbering balls like 1, 2, 3, 4, 5, 10 that you can distinguish them between them. All balls are having their individuality. Okay. But here we are just taking that 3 balls are blue, 2 balls are green, and 5 balls are red. So they are not distinguishable. Got it? Because there are 5 red balls, anyone can pick. Got it? So that is we are doing here permutation of indistinguishable objects where they are separated, some separation, but there are some indistinguishable item also. So the formula is this one. So in this case, where in this example, n is equal to 10, there are total 10 balls, but n1 is 3, n2 is 2, and n3 is 5. So how we can find out the permutation? That is what? Permutation of indistinguishable objects is equal to what? So it will become 10 factorial divided by 3 factorial multiplied by 2 factorial multiplied by 5 factorial. Indistinguishable means they are not able to distinguish properly. Individual. Okay, they are having some set of groups. For example, in this one, I'm just groupize the students city-wise. Okay, how many students from Chennai, how many students from Bangalore, how many students from Mumbai, how many students from Delhi, how many students from Plani only. Okay, so I'm just taking this indistinguishable. Okay, so we are just saying, okay, that this 5 students are from Delhi, 2 students from Chennai, and so on. Yes, this formula is for combination 6C4. An indistinguishable permutation for indistinguishable, this formula is there. Okay, just a minute. Is it clear to all of you? So there are other type of situations, then we are using the different formula here. Okay. So now you are just saying about the example. I'm taking the example. If the order doesn't matter, okay, so we are not using the permutation. If order doesn't matter, in how many different ways, can 4 out of 18 robotics arm will be chosen for a special welding job? Okay, so 18 robotic arms we have, and we have to select the 4. Okay, in how many ways? Got it? And we can select only 4, but they are having individuality, but we don't require the order. So what you will do? Without using the order, what formula can be used? Combination. So it means what? Here we are using 18C4. Okay. 18C4 means what? 18 factorial upon 4 factorial into 18 minus 4 factorial. So it is what? 18 factorial, 4 factorial, and 14 factorial. Got it? So it is in 18C4 ways without order. Got it? I already told you, Mr. Amrit Raj, we don't require any order actually. So we have to select the 4 arms out of 18. Yes, Mr. Mitesh Kumar, it is correct. Okay. And you can find out like this one, 18 multiplied by 17 multiplied by 16 multiplied by 14 multiplied by 14 factorial. And here it is 4 multiplied by 3 multiplied by 2 multiplied by 1 multiplied by 14 factorial. They are cancelled out. You can also simplify it. 2 is cancelled out here, this 8, and 3 is cancelled out with this 5. 4 is cancelled out by 2. So we are getting finally what? That is 18 multiplied by 17 multiplied by 2 multiplied by 5. Okay, that is the easiest way to calculate the combination. Now it's clear to all of you. Now one more example. That's the thing actually I am trying to explain here. That how you can identify where we are using the permutation, where we are using the combination. If there is no order is not important, then we are using combination. If order is important in somewhere, yes, then we have to go for the permutation. We are doing it, don't worry. A carton of 12 rechargeable batteries contain one that is defective. In how many ways can the inspector choose 3 of the batteries and get the one that is defective? Not get the one that is defective. So out of 12, they are choosing 3. So how many ways they are getting it? Okay. So how many ways they are getting? 12C3. Again, order is not defined here. Okay. Out of 12, we are choosing any 3. So there are 12C3. This is 220 ways to draw the 3 rechargeable batteries. A part, that get the one that is defective. Okay. So 11C3 is the ways to draw none are defective. How we can say 11C3? Any one of the student can explain it? How we can say 11C3 are the ways to draw none are defective. Only one is defective. Correct, Mr. Pankaj, actually. So 12 minus 1, that is 11 batteries which are non-defective. So we have to exclude 1. Correct, Mr. Akshay. Okay. So that's why we are saying 11, which is non-defective, and we have to choose the 1. Okay. So that is 165. So the number of ways to get 1 that is defective is 220 minus 165. So that is 55. B part, not get the 1 that is defective. There are 165 ways to get not is that is defective. Okay. Clearly? Nitesh Kumar. Okay. So that is the way most of the time, we are choosing the probability case. So we don't require the order. We require many times they are just possible combinations. Okay. Orders are not matter. Order matter if we just go for the previous class. In one example, I gave you that first is coming head, then second is coming tail, then third is coming head, and so on. If we are making that type of sequence, then only permutation is required. Otherwise, what is 4 coins are tossed, and we are checking one by one that how many times head is coming, how many times tail is coming, and so on. Okay. So at the time, if we are saying how many times the head is coming, if we toss a coin, time. So we're checking is coming 4 times is coming. We are saying okay 3 times they are coming head. So that is a combination. But if we are making the sequence, okay. My voice is breaking. This is for all. Oh, I will check. Just wait. I don't know why there is some connectivity issues right now. Now it's okay. Is it okay right now? Okay, fine. I don't know. There is some connectivity issue. Okay. So when we are using something in the order, then we are using the permutation. Otherwise, just for the selection purpose, we are just using the combination. Correct? And that is the way to calculate the number of ways or number of elements in the sample space, basically. In any set, in the sample space, or we can say in the events. Okay? That is the way actually. So three ways I told you: permutation, combination, multiplication. There are three ways just to find out the number of elements in the sample space and any event according to the given information. Is it okay? Now, section 3.3, that is the probability. How we can calculate the probability? Okay. So there are three ways which we are discussing here about the probability. So first is what? Personal approach. Okay, personal approach means what? There is not an authentication. That okay? Are the slides visible? Okay, fine. Thank you. So first is the personal approach. Personal approach means what? It is depend upon the experts only. At any time, they will just say particular. I gave you the example of the permutation also. Most of the time, we are using the combination. Okay, now screen is permutation means what? When we are arranging the order. Okay, and in the probability case, most of the time we don't require the arranging the order. We just require the how many times we can do it. Okay, I already gave you the example. If we toss a coin and we are just arranging that head first time is coming, second time tail is coming, third time head is coming, fourth time tail is coming. At the time we are arranging them, then only we can use the permutation. Okay. Otherwise, what we will say, how many times the head is coming, we are checking it. Okay, how many ways the head is coming. So at the time we are using only combination. Okay. The first way, so the first way to calculate the probability is the personal approach. Means anyone can say that I can say the probability of rain today is 0.7. 165. How it is coming? 11C3 is 165. That's correct. Now what we will do, again the problem is a voice, because I'm not saying anything right now. Okay, so now come to the probability. So in the probability, so first is the personal approach, then anyone can say anything. It is based on the expertise of that person. Okay, so that's why they are saying there is no authentication of it, there is no mathematics involved in that one, the personal approach. You can just make a one statement according to the your view, your perception, or your expertise. You can just make any commitment or any statement related to the probability. Okay, that is the personal approach. So in that one, no information is required, always applicable, anyone can say anything, but there is no authentication of that. Okay, no mathematical authentication. So that is the disadvantage, and we are not going for that specifically. Okay, now the second one is the relative frequency approach. Relative frequency approach means what? That is, probability of any event A can be written as the number of times the event A occurred divided by number of times experiment was run. So we are doing the experiment. So for example, we are tossing a coin. Okay, so we are saying now we are tossing a coin 50 times. We are tossing a coin 50 times. So number 50. How many times the head is occur out of 50? Okay, so let us suppose that it is a you can say in the 50 tiles. So it is what? 30 by 50. We are on the probability slides. Voice breaking again. No voice issue, ma'am. Okay, thank you, Mr. Aslam. I don't know, actually. There may be a connectivity issue. I don't know. Okay, so we are just tossing a coin 50 times and 30 times the head is occur. So it means what? The probability of occurring head is equal to what? 30 divided by 50. So we are just running the experiment, and we are saying here that is coming in the denominator. How many number of times we are running the experiment and how many times that particular event A is occurred. So that is known as a relative frequency approach. Okay, I already occurring the head is what? 30 by 50. Okay, so same another example we can make for that. Next is the classical approach. Just a minute. I'm sorry. I'm not feeling well right now. What we are doing? Single outcome by Mr. No voice? Now voice is audible. Okay, thank you. Slides are visible? Okay. I don't know what happened in between. Okay. So when you are performing the experiment, sometimes it's very difficult to run the experiment. है ना? You are tossing a coin 50 times. So it is very difficult to do it. And sometimes you don't have the coin. So what you will do? Okay. So I'm just giving a one example. So you have, it's very difficult to run the experiment so many times. So that's why we are not using the concept of relative frequency. So what we will go, we are just going for classical approach. So what is the merit of relative frequency? That is giving the over the personal approach, that is, it will give you the mathematical authentication of the finding the probability of any event. The second is the disadvantage. What is the disadvantage? That we have to perform the experiment so many times. है ना? We have to perform the experiment. But if you don't have the coin, if you don't have the dice, if you don't have the player cards, so how you can perform that? Okay, any type of experiment, you don't have the their you can say the equipments. So what you will do? So you can't perform the experiment so many times. So what we will do? We will go for the third method, that is known as the classical approach. And at the time we are not performing the experiment, what we can say, total number of possible outcomes and number of favorable outcomes. Okay, so in this one, if there are m equally likely possibilities, here it is very important that equally likely. Classical approach we can apply when they are equally likely only. Okay, so if they are equally likely only, then we can apply. I will do it. Don't worry. Okay. So out of which one must occur and S are regarded as favorable or a success. Okay. So then the probability of success is S by M. Now we are just performing the same example. Coin. Okay. We are taking a very fair coin. Fair coin means what? It is unbiased. Okay. So, what are the possible outcomes if we're tossing a coin? Two. Okay. And the event occur head. How many times it can occur? It is one. So the probability of coming head is what? 1 by 2. They are equally likely. Then we can apply this approach here. We don't have the coin, but we know the how many possible outcomes. That is head and tail. So only two possible outcomes. And what is the coming? How many times the head will come? Only one time. Okay, if we're tossing a coin only one time, so head can come one time. Okay, so it's like a S, this is a head and tail. The event A is what? Head is coming. So there are a number of elements. We can say number of elements in A is equal to 1. Number of elements in S is what? 2. So probability of A is equal to 1 by 2. But it should be equally likely. Correct? So that's why it is equal to the S by M. M is the equally likely possibilities and S is time when it is coming favorable case. Okay, favorable case. So if I am saying here to students, is it visible or the slides are visible? So I'm just talking about the how many favorable cases are coming here. Okay, if more favorable cases are coming, I can move further. If students are saying that no, slides are not visible, then I have to check it. Okay, but only 2 or 3 students are saying slides are not visible, but other students are saying the slides are visible. So what I will do? I will go for more number of students. So what is the meaning of that? The probability of visibility of the slide is more. Yes, correct. Yes, maximum students reply. So I will go for that now. How many students are replying? Okay. And to find out the accurate probability, that is not meaning of the accurate probability basically, because accurate probability is what? Nothing is that. Okay. So we are trying to find out the probability. Depend that how much reliable it is. Okay. Because we don't know the exact value of the probability. Okay. So these are the three ways to calculate the probability. So whatever the information is provided to us, accordingly we can use the either relative frequency or classical approach to find out the probability. Okay. So probability of an event, how we can find out? 1 is equal to NP is equal to P is equal to 1 by N. Hence A is an event consisting of K of these outcomes basically. So probability of A is what? K by N here. That is the number of favorable outcomes divided by total number of outcomes here. One more example we are taking here. A simple example. If a card is drawn from a well shuffled pack of 52 cards, find the probability of drawing a red king. I don't have. Just give me one example. Firstly, I will give the example, then I will move. Okay. I don't have the card right now. Okay. But I know that there are 52 cards are there. Okay. A red king. Red king at 2. There are favorable cases are 2. And how many cards? 52. So 2 by 52. Okay. Now you know it. Okay. So that is the classical approach. Because we know the how many possible outcomes, 52 possible outcomes, but how many favorable cases are 2. The red king are total 2. Okay. Now example, now we can say a 3, 4, 5 or 6. 3, 4, 5 or 6. So the answer is 16 by 52. Now how? Please tell me. I'm waiting for your reply. How we can say 16 by 52? How, Mr. John, you are saying 16? 4 multiplied by 4. Correct. So I believe that everyone, most of the students are able to get it. That 4 threes, 4 fours, 4 fives, and 4 6. All 4 type of cards. And there are 4 cards we are talking about. So 4 multiplied by 4. These are the 16 favorable cases to us. Total 52. So 16 by 52 we are talking about. Black card. Correct, Mr. Malay. How we can say 1 by 2? That is 26 black cards, 26 red card. So the favorable case is what? 26 by 52. Okay. So that is what? 26 by 52. a red ace or a black queen. So what are option here? Red ace. So there are two red ace and two black queen here. So it is 4 by 52. Okay. So I don't have the card right now. So we are applying the classical approach. And what is the assumption we have to take? They should be equally likely. Okay. Where is it written? Red ace is 2. In the card, there are 2 red ace. No problem. Actually, if you just go back to the history of probability, so it was started just for gambling purpose only. This probability theory started only for the gambling purpose at the time of introducing. Okay, for gambling purpose they are starting the probability, because nowadays also most of the time in the gambling games only we are using the probability theory most of the time. Yes, we can get. That's the thing actually I'm just trying to say here, that for gambling purpose we are using the in past uh, a mathematician just introduced the probability theory just for the gambling purpose only. You can find out maximum chance of highest probability for win. It is by chance only, but you can do like this one. Okay. So uh, nowadays also, when you are saying this are video games, when you are just talking about the different gambling games, they always the persons who are just involved in the making this type of gambling games, they are using the probability theory to just develop a system. Okay. So you can see here in the chess also, in the playing cards also, some are experienced, so much experience, then they are just winning. Okay, so because they know all the concepts of the all the different type of probabilities. Okay, then only they can just move accordingly and then they can win. So that's the thing actually we are in the gambling they are doing. They are trying to find out what type of probabilities can come, what type of possibilities are come in that one, and what are the probabilities. Then only they can just try to find out where is the maximum probability to win. Actually, they are calculating it. Now, 5 minutes break. Okay, fine. So this is the one example. Okay, I'm just taking a 5 minutes break. I'm just taking only the 5 minutes break only, and in between you just give me the answer of these 4 questions. Oh, most of the students have completed this one. That's very good actually. So a pair of balanced dice is thrown. So there are two dice we are taking, two dice. Find probability of getting a sum equal to 7. Okay. So we can just take here. Answer is 6 by 36. Okay. Because summation is coming 36. So all possible combinations are coming here. And the favorable cases are 6 here. Okay. That getting sum equal to 7. Any student having any doubt in this case? Okay, not getting. I will just do it. Now you are getting the 36, the denominator. Okay. So here we are just taking the two dice and that same example we have done S. S is the addition, two dice. So 1, 1 combination, 1, 2, 1, 3, 1, 4, like this one, and 1 comma 5, 1 comma 6, 2 comma 1, 2 comma 2, 2 comma 3, and so on. They are coming. Okay. So these are 36 combinations are coming. So that's why final. Okay. Now how we are getting the 7? 7 option. So it is 1 into comma 6. Here 2 comma 5. So 1 comma 6, we can say 1 comma 6, 7, 2 comma 5, 3 comma 4, 4 comma 3, and 5 comma 2, and 1 comma 6 comma 1. Okay. So there are 6 options. So 6 favorable case, 6 by 36. Now got it? Similarly 11. So there are 11. We are getting the answer is 2 by 36. Now 7 or 8, both. So 6 plus 36 divide plus 2 by, sorry, 2 by, 1 minute, 2 by 36. Okay. 2, 3 or 12. So all options we have to consider, or so it is 4 by 36. That is only 1 by 9. Now you get it? Mr. Malaya, Mr. Rudresh, Mr. Gaurav. Yes, there are two different dice. Only D not clear, because you can find out how many times the 2 is coming. There are only one option, 1, 1 and 1, 1. 3, very less options. 3 is coming. 1, 2 and 2, 1. And 12 is coming. Only one option. Okay. So after doing this one, now you got all the things. So 3 methods we have done to calculate the probability. One is personal. Second is the relative. Third is classical. Okay. So most of the time we are using the classical. What are the demerit for the classical? That is, it should be equally likely. Okay. It should be equally likely. If it is not equally likely, then what we will go? We have to go for the axiomatic approach. So the fourth approach to calculate is axiomatic. Axioms of the probability based on the axioms only. So if they are not equally likely, means what? We are taking the not a fair dice, not a fair coin. Thank you, Mr. Rohit. I am reading the chat. That's why my voice was not there. So here, this is the fourth one. We are taking the axioms. So that is the section 3.4. Then we are finding the axioms of the probability. So based on if they are not equally likely options, if the cards we are taking, it's not fair cards. Fair cards means some cards having a, you can say the weight is more. Okay, they are not equally likely. So at a time they are biased. So for that purpose, we are using the axioms of the probability. So to find out the probability, we are using the axioms of the probability. Okay. So based on that, there are three axioms here. So given an random experiment S, okay, let S represent the set of all possible outcomes. It means refer to a sample space. Any set of outcome is referred to as an event. Any subset basically of outcome is referred to as an event. So to each event A, we associate a real number that is PA. So you know very well. It is a balanced die. Definitely it is a balanced die, Mr. Malay. But there are two different dies. So first you will see the first dice and then second dice. And then you can say, okay, 1 plus 6 and 6 plus 1. If you are making the sample space, you can see the sample space. How we are making the sample space. You have to make the sample space then in this manner only. Okay. So we are saying here that PA, that is the probability of any event, is a real number between 0 and 1 only. Okay, because probability of any event always between 0 and 1. So this real number PA is called the probability of that event satisfy the following three axioms. Three axioms we are taking, and these are known as the basic axioms of the probability. And based on these three axioms only, we can go for the to find out the any type of probability. Any type of probability in any random experiment, we can find out the probability by easily by the axioms of the probability. What are the three axioms? For any event A, the probability of that event is always be between 0 and 1. I already told you it is between 0 and 1. A probability always be between 0 and 1. One example I am just giving you. Some layman person are saying there is a 40% probability. So that is wrong. Okay. Probability never be in the percentage. Probability always between 0 and 1. So that is what? 40% chance. Okay, that is not 40% probability. So a layman person can say that it is a 40% probability, but a mathematician or because you have done a course of probability and statistics, so you are saying 40% chance or the probability of that event is 0.4. It never be in percentage, it never be beyond 1. Okay, so it is between 0 and 1. So probability of any event always coming between 0 and 1. Second thing is what? That probability of the sample space always be 1, because we are taking all possible combination. Favorable case divided by the all possible combination, it is always coming 1. And if A and B are mutually exclusive events. Now you know about the mutually exclusive events. What is it? Anyone can tell me? What are the mutually exclusive events? In the last class we have done. Correct. They can't occur together. So it means that A intersection B is a null set. Okay. So we are saying here, if they are mutually exclusive events, so probability of A union B is equal to probability of A plus probability of B. Okay. Probability of A union B is equal to probability of A plus probability of B. Okay. If A intersection B is equal to 5, if they are mutually exclusive events. Correct? So these are the three axioms, and based on these three axioms, we can calculate the any type of probability of any random experiment. Clear? Now, we can just extend this third axiom. It is denoted by 3 dash. So it is what A1, A2, A and B is a sequence of pairwise mutually exclusive events. Okay. Pairwise means what? A1 intersection A2 is equal to 5. A2 intersection A3 is equal to 5. A1 intersection A3 is equal to 5, and so on. Okay. So these are the pairwise mutually exclusive events. So their union can be defined as probability of A1 union A2 union A3 up to AN union of all is equal to the probability of A1 plus probability of A2 plus and so on plus probability of AN. Got it? So that is the extension of the third axiom only for the n events basically. Got it? So initially we are talking about the 2 events. Now they are just mentioning it for the n events. So these are known as the 3 axioms of the basic axioms of the probability. So the complete probability theory depends or based on these 3 axioms. Whenever you just go for the probability, these axioms always satisfied. Otherwise, it is not related to the probability theory. Got it? Now, after that, using these axioms, we can just find out some more results. And after that, axioms are only 3. But based on these axioms, some results we are getting, which we can use frequently. What are the first result? Probability of null set is equal to 0. Okay. So as we are saying, A and B are the mutually exclusive events. So A intersection B is equal to 5. So probability of A intersection B is equal to 0 for mutually exclusive events, A and B. So if A and B are the mutually exclusive events, so A intersection B is equal to 5. And by result, we can say probability of 5 is equal to 0. Okay. If A is subset of B, then probability of A is always be less than equal to probability of B. Probability of A is a real number. So that's why we can't say it is a subset or subset, but A and B are the sets. So that's why if A is a subset of B, so probability A always be less than equal to probability of B. That you know very well, probability of A is always between 0 and 1, and probability of A complement. A is a set, so A complement is also be set. So the probability of A complement is equal to 1 minus probability of A. Okay. So these are the frequently used results which we can derive, which we can find out by using the 3 axioms. And we are not extending the axioms, but these are the, I will give you the example. Don't worry about it. These are the theory. Firstly, I will explain the theory and then I will go for the example. No? Okay. So these are the some more results which is based on the axioms only. Later on, whenever it is this condition arises, we can use this formula directly. Okay. That probability of A complement is what? 1 minus probability of A. Probability of null set is equal to 0. Empty set is equal to 0. And if A is subset of B, then probability of A always be less than equal to probability of B. Last line is what? Probability of A complement. If we are making a Venn diagram, in the last class also I mentioned the Venn diagram. This is the A set. Okay. This is S. Got it? Now, A complement is what? This one. Okay. So the probability of A complement is what? Probability of S minus probability of A. And probability of S is what? 1 minus probability of A. Got it, Mr. Mahinder Singh Rawat? Okay. After that, we are just doing some elementary theorems. So we are doing some theory, and then we will do some examples related to the probability. Okay. So don't worry about it. We will do it. This one. This is the axiom, second axiom of the probability. Probability of sample space always be equal to 1. Okay. So some elementary theorems which we are discussing here. That first theorem is if A1, A2, AN are mutually exclusive events in a sample space S, then probability of A union A2 up to AN is equal to probability of A1 plus probability of A2 plus and so on probability of AN. Okay. So now we are just mentioning the rules for calculating probability of an event. Okay. So that is the previous one. That is the complement. I mentioned that this is the extension of the third axiom for case. If they are n mutually exclusive events, so we can write the probability of A1 union A2 into union AN, then they will become a probability addition. So if what we are saying here, they are mutually exclusive. So what we were doing here, that is probability A1, A2, A3, A4, A5. Okay. So we are just doing this one. We are adding this one. We are adding this one. We are adding this one. Okay. So here in the set theory, it is union. And we are finding a real number based on the probability of this set, probability of this set, probability of this set, and so on. So we are just adding them. Okay, so that is the extension of the third axiom of the probability. Clear? Now, one more example theorem we are doing here for calculating the probability. It is more important actually. If A is an event in the finite sample space S, then PA equals to the sum of the probabilities of the individual outcomes comprising A. Okay, sum of the probabilities. For example, sum of this probability, sum of this set, sum of the set this, sum of this probabilities of this set. Okay, so we are just adding it. The proof is what? Suppose E1, E2, En be the n outcomes comprising the event A here. Okay, now we have A is equal to E1 union E2 union E3 up to En. Okay. E's are individual outcomes and mutually exclusive. Okay. So therefore, we can say probability of A is equal to probability of E1 union probability of E2 union probability of En. Now you know it. Earlier also we have done 2 or 3 or 5. So what we are doing, we are finding the probabilities and we are adding it. So same thing we are doing, probability of E1 plus probability of E2 plus probability of En here. And they are mutually exclusive actually. Okay. Now, if they are not mutually exclusive, clear? So now the condition was, the axiom was based on the assumption that they are mutually exclusive events. If they are not mutually exclusive events, so how we can calculate the probability? So for that, this is known as the general addition rule in the probability. So what is this? Probability A, we can find out like this one. Probability of B, we can find out like this one. And when we are calculating the probability of A, this part is also coming. And when we are finding the B, so it is also coming. So this intersection part are coming twice. Okay. So what we will do, we have to add this complete one. So what we will do, we are just taking here minus 1 times probability of A intersection B. Okay. So this is A. This is A intersection. Oh, sorry. This part is A intersection B complement. And this part is what? This part is what? A intersection B. Okay. This part is what? A complement intersection B. It's not A plus B. Directly we can't say it is A plus B. है ना? So what we are saying here, probability of A union B, we have to find out the probability of this complete reason. So when we are just taking A, probability of B, so this reason is coming twice. So we have to subtract once. So here it is A intersection B, it is this part only, this vertical line. A complement intersection B is what? This line. And A intersection B is this line here. Okay, the shaded region. This. And this is the probability of A union B. The whole three things here. Okay. So if A and B are any event in the S, then probability of A union B can be written as probability of A plus probability of B minus probability of A intersection B. Why I'm just telling again and again probability of A intersection B. Now we are saying it is mutually exclusive events. So it means what? A intersection B is equal to a null set. Probability of null set always be 0. So that's why if they are mutually exclusive event, then formula is just went to the axiom of the probability. Okay. Now we relax the condition that they are not mutually exclusive. Then this we are using the formula which is known as the general addition for the proof. So as I told you, A union B is what? A intersection B, probability of A intersection B complement. Just a minute. Plus probability of this one. Okay. What is the meaning of that? This one. So here this reason, and this reason. Three reasons we are talking about. Okay. And these three reasons are mutually exclusive. So now we can just use it. Probability of A intersection B plus probability of A intersection B complement. So here what we are doing, we are just using here plus probability of A intersection B again minus probability of A intersection B again. Okay, plus minus we are doing. So this plus is combined, this one. We are making this one combination and this is the same. Now A intersection B and A intersection B complement will become, if we are just seeing this one, this is A, this is B. Okay, so A intersection B complement is this one and A intersection B is this one. So it is what? Probability of A, the complete set A. Okay, similarly, if we are talking about the probability of A complement intersection B is this. A intersection B is this. So this will become B. Okay, this will become completely A. So probability of A plus probability of B and minus probability of A intersection B is already be there. There are so many ways to prove it. You can use by any method here. So when A and B are mutually exclusive events, so at the time A intersection B is phi, that is the null set. So probability of A intersection B is equal to 0. So that the time probability of A union B is become here probability of A plus probability of B. Okay. Now probability rule for complement, I have already mentioned probability of A complement always be equal to the 1 minus probability of A here. Okay, so in this one, the same concept we are applying here, that this is the A, so this is the complete A complement here. Okay, so they are mutually exclusive events whose union is S. So probability of A union A complement is what? Probability of A plus probability of A complement. This is what? Sample space. The probability of S is equal to probability of A plus probability of A complement. Probability of S is what? 1. So probability of A complement is equal to 1 minus probability of A. Whenever it is required, we can apply it. If A, probability of A you know, and you are trying to find out probability of A complement, you can use this formula. These are the formulas. Okay, so it is like a sample space. There is an event A, so this is the probability. This is the A complement, and then we are trying to find out the probability of S is equal to this. Okay, now come to the example. So these are the some formulas. You can see now. This is the sample space. This is A only. So A, and this is the complete A complement. So it is a sample space. So probability of A union, or you can say the A union A complement, always be the sample space. Any event we are talking about. Okay, now we're just taking a one example. Assume that in a particular military exercise involving two units, red and blue, there is a 60% chance that the red unit will successfully meet its objective and 70% chance that the blue will do. Okay. There is an 18% chance that only the red unit will be successful. Only the red. What is the probability that the both units will meet their objectives? Okay. So we are finding that both the units will meet. So we have to find out the probability of A intersection B here. What is the A? That is the red unit successful, and probability of A is given 0.6. Okay. B is the event that blue, sorry. B is the event that blue unit successful. So probability of B is equal to 0.70. Okay. Now what is given here? Probability of A intersection B complement is 0.18. Because it is given 18% chance that the only the red unit. Okay, not the B unit. So A intersection B complement is probability is given as 0.18. So by Venn diagram, we have to find out the probability at A intersection B. So I will just make you the line probability Venn diagram. Like suppose we are making the Venn diagram. This is A, this is B. Correct? A, this is B. Got it? So what is given? Probability of A is given. You know, I will change the color. So probability of A is coming given is means this one. Okay? Probability of B is given as like this one. The complete one. Okay? Just a minute, I will tell you. Now the third is given only the red unit. So we are just talking about this. Red unit, only the red. So there is not considered this part also. I will change the color also. They are not considering this part. Only the red, this part. So what is this? A is yes, but B is not. Okay. So this is this part here. This part is A intersection B complement. Because we are excluding the B part also. Okay. So this part is A intersection B complement. That is the only red will do it. Okay. So it is 0.18. Now what you have to find out? Probability of A intersection B you have to find out. So A intersection B is this one. So what you will do? Yes. So probability of A intersection B is what? Probability of A, the complete probability minus this part. So I'm just changing the color. So what we are saying? Probability of of A, the complete reason. Let us suppose this complete reason, and we are removing this part. Okay, so we are removing the probability of A minus A intersection. This part we are removing, so we are getting the this part here, A intersection B. So by the Venn diagram formula, we are just making from the Venn diagram only. Again, I am making a Venn diagram. This is the S sample space. There are two events A and B. Okay, now we are just saying here A. A is what? This part. And then B, we are saying this part. This part is the B. Okay, only A we are talking about. It is what? This only A. B is not there. Okay, so this is what? A intersection B. And this is what? Only A. So A intersection B complement. Okay, and now we have to find out this reason. So how we can find out? So A, we are subtracting the A and this part, that is A intersection B complement. So that is the probability we are finding, probability of A minus probability of A intersection B complement. Now it's okay, Mr. Rahul. Just plug in the values in the formula and you will get the answer. Most of the formulas we are making by using the Venn diagram only. Next is, what is the probability that the one or the other but not the both units will successful? Okay, either one or two. So we are just saying A intersection B complement or A complement intersection B. So it means what? If we are just making a Venn diagram like this one, so what they want? They want this one or this one. Okay, they don't want this shaded area. So this is what? A intersection B complement, and this is what? A complement intersection. Okay, so that is, we are saying probability of A intersection B complement union A complement intersection B, and these values you know, that is 0.18 and this is 0.28, which is equal to 0.46. In the Venn diagram, we can mark the A. And from that A, we can find out the probability of A. A is what? This complete circle. 0.28 is what? Probability of A complement intersection B. That is what? Probability of A intersection this one. So what you will do? Probability of B minus probability of A intersection B. You can just use it. This is completely probability and we are using this one. We are subtracting this one. So that is what? Probability of B is 0.7 minus A intersection B you have already calculated. That is 0.42. It is 0. Are you getting my voice? I'm not getting any reply from your side. Yes, complement means is excluding. Complement is excluded. Here, which we are theorem we are using, it's a probability of space, sample space is equal to 1. All axioms we are using here. All three axioms we are using. Based on that only we are making the Venn diagram. Okay. Now one Venn diagram is given like this one. I think the questions are just, I missed the question. Okay. They just change it. Okay. Yes, whatever it is, not in A. That is the complement. Okay, A is the rad unit successful and probability of A is 0.60. The solution is given like this one. We have already done this part. Now, one another example, a car rental agency has 18 compact cars and 12 intermediate size cars. So there are two type of cars. Mr. Malay, actually in mathematics, we have to use the symbols. Okay. So you have to be remember these symbols specifically. These important symbols actually. The complement, union, intersection, set, subset. Definitely you have to remember these notations. A car rental agency has 18 compact cars and 12 intermediate cars. If 4 cars are randomly selected for a safety check, again you just check randomly selected. So what the option we have to choose? Combination. है ना? To find out the probability, we require the number of favorable cases. So how we can do it? By using the combination, because here we are not taking the permutation for that. Only we are selecting. So 4 cars are selecting. So total number of cars are what? 18 plus 12. Okay. Out of 30, they are choosing the 4 cars. Got it? For a safety check. What is the probability of getting 2 of each kind? So how you can do is, there are 30 cars. So we choose 13C4. That is the total number of possible bays. Choose the cars for inspection. Okay. There are 18C2 ways to get the first compact car and 12C2 ways to get the intermediate size cars. So thus the required probabilities is what? 12C2 multiplied by 18C2. This is the favorable cases divided by 30C4. Okay. How many times the number of ways for this and this? So this is the favorable case divided by total number of possible options. Another example, the probability that a new airport will get an award for its design is 0.16. The probability that it will get an award for an efficient use of material is 0.24. So there are two types of awards: for its design, for efficient use of material, and the probability that it will get both awards, 0.11. Okay. So there are two awards. Now there's the probability of winning the awards basically. Got it? Now, what is the probability? So now what you can say here? Now we are just defining the events. A is the event that getting the award for design. Okay, B is the event getting the award for material. Efficient use of the material. Okay. What is given here? Probability of A is given here 0.16. Probability of B is also given 0.24. And both awards is given. Probability of A intersection B is given as 0.11. Okay. Now what they are saying? What is the probability that it will get at least one of the two awards? At least one means what? A part. At least A or B. Yes, I am just winding up. I am just telling you the formula only. So it is by formula probability of A plus probability of B minus probability of A intersection B. Plug in the values, you will get the answer. Okay. B part, what is the probability that it will get only one of the two awards? Okay. Only one award is means at least one award minus both awards. So it is 109 minus 0.11. So only one award, either this or this. Okay. So that is what? At least one award minus probability of both awards. So it is 0.18. So that is just a formula based question. So go through it. I will upload the slides. You just go through it by your own. Any doubt in the next class, you will discuss with me. Thank you. Thank you so much. I am winding up today. My suggestion always be the same for the mathematics course, that you have to do the practice. If you're doing the practice, then only you can remember the concept. Otherwise, it's very difficult and it's very confusing also. In every course of the mathematics, there are so many concepts, and you have to, if you're trying to remember, it's very difficult. The previous class slides already uploaded in the corrected version. Thank you. Thank you so much. We are using the general addition rule. So thank you all. I am winding up here. Thank you all. I have uploaded the slides already, and today's also I will upload it. Okay. Thank you. Thank you. Thank you so much.